All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are back. I did miss stream last night due to some technical difficulties, and by the time I got everything straightened around, really just wouldn't have made sense to stream because I wouldn't have been able to stream for all that long. So we're just going to pick up tonight where we would have picked up last night, and that is from last week's stream. And as you can see here, I did make a little bit of progress offline, though, at least getting things back up and running again. So tonight we're going to continue with our integration of the new animation system into our scene so that we can hopefully visualize an animated mesh here soon. Before I do that, though, I do want to just take a quick second to thank the supporters of the channel, beginning with the elite partner Javier Olazaran, followed by the partners Goblows Inc. and Matt Osgard. Those are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. They are a combination of the other tiers of support over on YouTube memberships and Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated and helps me cover the cost of running this channel and the project. Things like software licenses, hosting fees, things of that nature. And so that's greatly appreciated, and thank you very much for that. All that being said, I also want to extend a large thank you to all of you guys, the viewers, whether you're joining me here live on stream, either on the YouTube side or the Twitch side. We do simulcast both, or if you're catching the VOD after the fact. Either way, thank you very much for being here, because without you guys, this channel and thus this project would not exist. So just a big thank you to you guys. All right. RCW, good to see you. How's it going? Diminish, good to see you as well. Hope you're doing well.
07.
Psychode, good to see you as well. How have you been, buddy? Thank you so much for the tier 1 sub for 9 months. I really appreciate that support. Thank you so much. Yeah, I'm doing well. Thank you for asking. I just had some technical difficulties last night. Specifically speaking, my streaming machine needed some updates, and some of those updates caused some problems, and it took a lot longer than I thought it was going to. And so by the time I got all that stuff squared away, I'm like, it doesn't really make sense to stream. So I didn't stream last night. We may wind up doing a makeup stream. We'll have to see. But yeah, that was basically the reason we missed stream last night. So it's a streaming PC running Arch as well. No, the streaming PC it's actually the Mac that I use for porting this to Mac OS. It's a powerful enough machine to handle it. It's just it needed a rather large OS update, and that took forever to actually put in place. So yeah. But yeah, it's all up and running and all good now. So no worries there. It's actually been very reliable as far as that is concerned. There's been very few issues in that regard. If anything, I've had more GPU issues on this main machine that you guys see here than on that machine. So it's been pretty reliable, I have to say. All right. So what we're looking at here is I basically have things back up and running, kind of where we were before. So we've got our materials showing up, although it doesn't look like our emissive maps are showing for some reason. I just noticed that actually. Because this 512 by 512 should be illuminated. So I don't know why that's not showing. And there's some weird stuff going on with the water. And I think that's because its normals are messed up. So its normals are saying it's on the Z axis where it should be on the Y. So there's a couple things to fix there. I don't know if there's too much value in fixing that here on stream. So I'm not going to worry about those things for now. What I'm going to do is continue tying in the animation system into the scene and get, hopefully, things up and running on that regard sometime soon. Linux and GPU drivers is a match made in hell. Yeah, it used to be a lot worse, and it's especially worse because this machine runs an NVIDIA GPU. So a couple years ago, it was way worse. It's actually been better these days, but yeah, it's still not great. One of these days, I actually need to probably run a stream from the other machine that I have down here that has an AMD card in it, but that doesn't have a Linux install in it at the moment, so I'd have to use Windows on that one, which bleh. All right, so there's a couple things we need to do here in terms of integrating this stuff to work with the scene. So in Illumina main, just as a sort of refresher as to how all of this works, we build up all of our render data. In fact, I'm going to kill this other buffer over here for a second. We build up all of our render data or our data that we need for geometries to be rendered within Illumina main, right? And specifically prepare frame. So we basically just query the scene for, in this case, static mesh render data. We do a query on the scene for that. And then in the render data, we actually just go ahead and build up the geometry data that we need. This looks like it's for the shadow pass, which I'm actually not as concerned about that right off the bat. So I think what I'm going to do here is actually just put a fix me in, or I guess a to do. And we're going to want opaque and transparent animated geometries, I guess. And actually, let me move this down here. All right, and actually a little bit further. Right there. Okay. So the way that this basically works is we go ahead and query the scene for opaque, or I should say geometries that are using materials with, or opaque materials rather. So we query those first, we build up a collection of those, and then we also then grab the same type of data, but for transparent materials, which actually I just realized there's a bug in here. This should be, let's see, opaque geometries. Let me make sure I didn't do this. I might not have done this correctly, actually. Looking at it, that might actually be wrong. So let's see. Thinking we might actually have a copy pasta issue in here. So we have opaque material count. We go ahead and query the scene. We say, how many of these do we have? We don't pass any sort of render flags, which indicates that we just essentially want non-transparent or opaque geometries. And then we return that data here. So we have that render data, then we go through that render data. And we actually just put them in to opaque geometries into that array within the render data. So that makes sense. And then we go ahead and set the count as well. And then we don't have to free this array, by the way, because of the fact that we're using it with a frame allocator. So it just gets wiped at the end of the frame anyways. So we do that, and then we add the drawn shadow mesh count. We just kind of increment it by that count as well. And then we do transparent materials next. So we go ahead and we grab the transparent geometries by material. Why are we not doing it all in one step like this? Oh, I think because the shadow data actually can have all of the materials grouped. That's why. Okay. Okay, so this actually is correct, but this should be... This is looking at opaque geometries, which is wrong. That should be... let's see, render data, shadow data, transparent geometries by material, sub I, geometry count. And then we don't need, whoops, I guess we don't need the D-array length. Okay, so that's not really a big deal. This was just for debugging purposes anyways, just to kind of give us a little bit of feedback on terms of how we're actually rendering this stuff. But essentially, you know, we gather opaque data, then transparent data for static meshes. So we would essentially need to do the same for animated geometries, and then the same would wind up being true for terrains. We gather terrain data after that. Terrains are currently turned off. And I don't know that we're actually going to wind up using terrains for this game. We'll see. So I may just leave that off for now, because that has several other requirements we have to put in place. I wonder if I should just do this. Since we're here, I suppose we could just bite the bullet and just kind of do it, right? So let's take all of this. Actually, I'm going to go all the way down here, take all of this, and we're going to put it into a scope. That way I can just rename things easier. And we're going to call this animated opaque material count. And then animated opaque material render data. And this is largely going to be the same call, except this is going to be animated mesh render data. Is the big difference there. So this was a function that we already had created in our scene, right? So it works the same as static mesh render data, except it's animated mesh render data, rather. So we already have that, so we could just hook that up there, and then this. So we have, I think it's just, isn't it? Do we not have that for this type? I thought we did. Evidently not. So we have opaque geometries. Let's see. So opaque geometries. Oh, you know what? I just had a thought too. We're actually going to have some problems in the shadow pass that we need to resolve. Okay. So we should probably do... I think I still want to set up the render object and pass it all the data. So what I'm going to do is we have opaque geometry counts, opaque geometries. I guess we could actually just... No, I think I am going to separate them. As crazy as that sounds. Because they do require different shaders. We can maybe combine them later. But for now, let's just do that. Actually, we also have opaque animated geometries, array of animated geometries. Oops. Did I just lose my changes? I think I did. Yeah, okay. We'll just do that. This is going to be animated mesh geodata by transparent material. Okay. All right, so now we can just do animated counts for all of these things. So this is just going to be animated opaque geometries. And then same thing is going to be true here. So we basically just prepend these things, right? So we have that. And then same thing for transparent ones. In fact, I'm going to clear the highlights real quick. And then we do that. I think I got them all. Like Pokemon. All right. So that's no longer a to-do. We at least have those in there. Okay, so the forward pass is the next place that we're going to have to do this. Essentially the same thing. Oh, it looks like did we already do this in here? I guess I just didn't do it for the shadow pass. Interesting. Animated meshes with opaque materials. So it looks like we did do this then. Okay, so I guess maybe we just have to hook this up in the renderer. I'm not 100% sure why. Yeah, it looks like we already did hook this up. Okay, so this is the forward pass, and within the forward pass it's the standard pass. So we should at least see this thing show up if it exists. And the water plane stuff should essentially be the same thing. Animated. Yep. Okay. So I guess we do have these. We're further along than I thought we were. It's never a bad thing. All right. There we go. Is the streaming PC running art? Oh wait, no, I already read that one. Really did when we were stuck with Nouveau. It was not great at all. Nouveau? I'm bad with French. Nouveau, I think it is. Was not great at all. Yeah, I mean, I always resorted to having to use the proprietary drivers, unfortunately. We did progress despite all the problems that still occur. Yeah, it has been a lot more stable as of late. I will give them credit where it's due. From Lake, good to see you. Is this going to be a good stream? Well, I guess that remains to be seen. But how are you doing, buddy? I hope you're doing well. I'm sure we're going to have some Dingus-oriented programming on here, for sure. All right, let's go into the Illumina renderer. And let's see, draw geo list. List. Okay, so let's see, scene pass. So we already did hook this up as well. Okay. So we do have that. The only thing that I wonder about is we don't actually have a way to switch the shader between animated and not animated. That's going to be a bit of an issue. I guess what we could do is we could actually analyze this animation index. And if the animation index is set to invalid ID, then we just proceed with the normal shader. If it is set to anything other than that, then we'll go ahead and animate it or use the animated shader. Although I'd kind of like to see it just rendered on its own, but we actually can't do that because of the vertex data. Let me think about this for a second. Okay, so we do pull the size of the vertices directly from do we actually? Render buffer draw. Element counts. Where do we actually pull in the size? I wonder if that's going to be a problem. I wonder if that's going to be an issue or not. I'm thinking it might be, but let me build this real quick, and what we'll do is we'll go into the renderer, and we'll do draw geolist, and Apothum, thank you so much for the tier 1 sub for 10 months. Thank you so much for that support. I really appreciate that, buddy. Thank you. That means a lot. Definitely appreciate that support. Let me go into here. So let's see, we have this. Oh, you know what? I should probably do this. A breakpoint right there just to see. And do we actually have... I think that's our only breakpoint. So let me actually disable that one for now. And I want to actually run and load up a scene. But I want to see if this draw is actually triggered by anything. So we have animated mesh, animated opaque meshes by material count. Do we have? We don't have anything. Okay. What else do we have in here? Do we have transparent ones? We don't. Okay. So if we go into the scene, let's see. I think I want... what was that? What was that called again? So when we do this, it's Illumina scene get animated mesh render data. That's what it was. So this function. I want to actually put a breakpoint here. And we're going to continue. There we go. Okay, so we don't have anything in our opaque animated mesh material map. Okay, so that would probably be why. Because the map count is 0, so we're not going to get anything. All right, so let me double check. This, so we have a test anim here, animated mesh. I could have swore that was actually being loaded. There's the dancing vampire right there, attempting to load asset. Let's see. Doesn't look like the asset ever actually loaded. Well, that's problematic. That might be why we're not seeing anything. Okay. So, why is that? What kind of dingery have we got going on here? Let me think. Why would that not work? Attempting, whoops, to load asset. And let's actually go to the VFS. And, oh god, that's a lot of them. I guess we could probably do, let's do this at the higher level. So we want to request static mesh. Actually, not static mesh. Request is there no how are we doing? It's been a bit since I've looked at this code, so bear with me just a moment here. We have do we actually even have this in here? So we have do we actually even have this type handled in here, this entity type? I don't know that we do. I think that might be part of the problem. So on static mesh loaded, on animated mesh loaded, static mesh instance acquire from package. Okay. So this essentially, this is what does it for the static mesh. So this is the animated mesh portion of that. Do we have anything stupid in here? I don't know. Let's see. Animated mesh counts, seen animated meshes, blah, blah, blah. Do we actually have? So the static word isn't in here anyways, so I don't think we've actually copy pasted anything wrong. Animated mesh instance acquire from package. Okay, so this is the animation system. So if we take a look at this, we do know, at least from the logs, we do know, like, this comes from the VFS, right? So we do at least know that from the logs that it's at least the request is making it all the way to the VFS. However, it doesn't seem to be completing from there. So request model from package, that's fine. Okay, so this then says, here's the assets. Here's the context, the callback and the listener. We do have a callback and listener, right? Yes, animated mesh asset loaded. Let's do, yeah, we don't actually spit out anything to the console here. So let's actually just for ease of use or ease of debugging in the future, let's go ahead and do a kdebug, and we're going to do animated, actually we're just going to say model loaded, right? Because we're actually going to be changing this and condensing it at some point. And we'll put like a name or something there. So assets. Do we actually have the name in here? I don't think we do. Type listener. Do we have anything in here? We don't. Okay, I guess we won't do that. I guess all we'll do is the function name for now. All right, so we'll do that, and then also in K animation system, I'm going to go ahead and put a breakpoint on this just to, let's see, 186. Just to kind of confirm that we're actually hitting that that path of code, right? Let me stop this. And I heard a ding, so let me see what that is. Oh wow, raid. Let's see who raided. Fioramond, with a raid of 26 viewers. Thank you so much for the raid. Welcome, raiders. I really appreciate the raid. Thank you so much. What a time for ads. Oh, ads are... Well, I think they actually just finished. How's it going? Welcome, raiders. Thank you so much for the raid. What were you getting up to on stream? Let me give a shout out. And I don't believe I'm following you. So what were you getting up to on stream? Let me know. And thought ads wouldn't show if you rated it interesting. Yeah, I wasn't sure about that either, actually. But you confirming that is good to know. Magat's good to see you as well. You were studying the IEEE 754 spec and trying to implement float printing function for my string library. Okay, you know what? That sounds awesome. So I'm tossing you a follow. Highly recommend checking them out. Okay, done. Followed. Does a lot of C89 stuff. Cool. That's awesome. Well, I'm going to check you out next time I actually am online and see you on. So, yeah, thank you so much for the raid. What we are doing here, let me actually pull up, let's see, let me pull up my correct window here. So what we're doing here is we're building a game engine from scratch using C in Vulkan. It's called the Kohi game engine. So the idea here is that we're going to be, or that we are building a game engine from complete scratch. And you know, we're building it from the ground up to show a way of building a game engine. So it's not necessarily the only way to build a game engine. It's not even necessarily always the right way to build a game engine. We do a lot of trial and error and experimentation on the channel. Trying different things, seeing what works, what doesn't work, etc. And then doing deep dives into those things. And we have debugging sessions, and you know, the whole idea is to show the entire process of creating it, not just the shiny bits that, you know, show up in your typical tutorial series. You know, we've had we've definitely had debugging streams on here before where we're just, you know, fixing bugs. But yeah, that's kind of the idea, and then we're going to take that game engine all the way through to create a game and release that game on Steam. And so the game engine itself is cross-platform, so it runs on Windows, Linux, and Mac OS desktop environments. We do have other platforms planned for the future. I'd like to eventually target some consoles with this eventually at some point as well. The engine itself, the core engine, is free and open source. Because this is kind of an educational resource, I believe that stuff should be open and free, just to kind of encourage, you know, competition against the big three, to encourage people to kind of go out and write cool stuff on their own and not necessarily just do everything on Unreal, or Unity or what have you. And so the engine itself is Apache 2.0 license, which basically means that if you want to use it for commercial or personal, it does not matter. The only thing that I ask is if you use it, you just say you used it. That's literally it. There'll never be any sort of licensing fees or royalties of any kind associated with the engine. It's meant as an educational resource to be used to learn how to do this stuff, and hopefully to base your own stuff off of, and you know, pick out what you need, throw away what you don't, and go and make awesome stuff. So that's the idea here. And then a little bit of a flashbang here. Sorry about that. But the game that we're going to be creating is called Shadows of Illumina. It is a 3D isometric action RPG, or at least that's the design that we're going for. And so we've actually done a lot of this design here on stream as well. And so we've got a whole bunch of notes in here on things that we want to kind of include in the game. And most recently, we created a custom file format for models, and that's going to include both animated and not animated models, static and animated models, I should say. And so we sort of had this sort of separate static mesh system that's kind of a little bit legacy at this point that I'm going to be removing in favor of this. But for right now, our new animation system that we're tying into everything uses this format as well. And so that's kind of where we are project-wise. And we're debugging that right now to see why it's not working, essentially. All right, let me catch up on chat. Okay. Let's say I spent a few hours on it and didn't get anywhere. It's a lot over my head, and I need to reread the spec. My math knowledge is too rough for this, but I'm determined. That's fair. We do that here all the time too, so don't feel bad. Yeah, I do that with Vulkan a lot of times, and it just makes me question whether I know what I'm doing sometimes. When I get a seg fault or something from the driver. May not have gotten far code-wise, but you're digging, eventually it'll get done. Yeah, exactly. That's exactly the point. And that's what we do here too, so. I see C89, well, any C I follow. I'm the same way. Yep. Same way exactly, Apotham. Been really deep in fixing bugs, clearing off old to-do items, and learning and writing AVX assembly. Nice. That's awesome. I need to do a little bit of that myself. At some point. It's just been like a to-do item for me for a long time. Wrote my own AVX enhanced memcopy memmove functions. Ooh. Do you have those on VOD? I'd be interested in watching about that for sure. Nice, love ARPGs. Yeah. We're still kind of defining the rules around it, but I'm thinking like a kind of like a Diablo-like and or a Path of Exile-like, but maybe a little bit different in terms of how it actually plays. So yeah, I haven't fully fleshed it out yet. We've just kind of the main idea that I have is that I want to kind of try the mechanics once we get some of these core systems set up. I want to try some of the mechanics in the engine and see what feels good before we actually make final decisions on that. So we might be prototyping for a bit too. If I ever start streaming, I'll call my debugging streams anti-bug streams. And when I write code, I'll call them pro-bug streams. It's funny. Yeah, I call it bug extermination on occasion. Also very sleepy, so I might doze off shortly and not fully comprehend what's being written here. That's fair enough. I totally get that. But thank you so much again for the raid. You always stream so late for me. Yeah, I know. It's because I have to stream after work is the problem. AVX2 is amazing. Load up 32 bytes all at once. Yeah. AVX is pretty sweet. You don't publish your VODs, but you might publish AVX assembly code at some point, or a reduced version for educational purposes, since my implementation is tied into my build system, which has a conditional compilation for systems that may not include support. Yeah, okay, that's fair enough. Yeah, if you do publish that, though, I'd definitely be interested in that. Half of the reason that I started simulcasting between YouTube and Twitch is because like the VOD just kind of automatically goes to the YouTube side, which is nice. Singy, good to see you over there. Speaking of the YouTube side, good to see you. Hello. Would love to make an ARPG myself, just for that reason, to try out different mechanics and ideas I might have. I've got something like 12k hours in Path of Exile and have some ideas popped up during those hours. I bet. Want to let you know about Mudbound Dragon and Maget's oh, okay. I appreciate that from both of those guys. Yeah, Mudbound Dragon is freaking awesome. And Magetz, of course, is always hanging around these parts. So thank you to the two of you for that recommendation. In fact, I'm going to give a shout out to Mudbound. I don't think he's on at the moment. Let me see if this works. I might have to do... There, it did work. Okay. Yeah, Muds is cool. Yeah, agreed. Agreed. All right. So what we were talking about here is we essentially have created this new animation system. We have our, I use the term loosely, asynchronous asset loading setup. And so I'm looking to see why our new sort of models aren't actually loading up. And so that was what I was literally getting ready to debug when we started, or when the raid happened. So that's what I'm going to continue now. And it does look like we do have the animated mesh loaded callback being made. So my question here is, if we have done all the things, which actually, let's see, bones, nodes, this stuff is probably all fine, although it's relatively unexercised at the moment. Animations, I'm just going to skip down here. So let's just make sure that we actually have some of this stuff actually showing up as we might expect. Okay, so we do have bones and nodes showing up. We do have a single animation that shows up, so that seems reasonable. We haven't loaded any meshes yet, so that's the next thing I want to check. In fact, I'm going to skip all the animations and channel stuff and just go to the meshes. So let's check that. So there should be one mesh in here, which there is. That's good. Okay, so if we go through and do all of this, we have, let's see, all the way down here. Once we've actually loaded in all of the upper level geometry or submesh information, this is where we actually allocate space on the render buffer. So for the vertex buffer and the index buffer, which, let's see. So we allocate some space there. And we should have, that looks like, okay, that completed. And then we go ahead and we load this range in. So let me just make sure that, that this worked correctly. So we should load our vertex data here. So that's good. And then we do have index data as well. So we allocate some space in the buffer, load that up. And then we increment the generation from invalid ID to 0. Okay, so that is good. So if we're uploading all that stuff, why is it not? Let's see. Materials. Looks like we even were able to acquire the material. So that's good. And then all we have to do is oh, did we not actually finish? Okay. So that's the animator. That should be fine. And then we release the model after that. And then we clean up the listener. I feel like we missed a step here. So, in the, I guess we should probably look at, the static mesh system. So let's go to the callback for this. We didn't make the callback, did we? I think this is the bit we're missing here. If we take a look at the If we take a look at this, let's see. Go to the bottom of this. There it is. That would be why. Dingus-oriented programming at its finest, ladies and gentlemen. All right, so we have type listener callback, and the cool thing is none of that stuff was filled out, which is awesome. So the general idea is here is that this is the callback that's made from the VFS, the virtual file system, when that asynchronous asset load completes. However, the user code, the thing actually requesting said asset, also has its callback and context that need to be supplied. And so, like if we take a look at this, oh, that's going to be behind my head, isn't it? I'll just go to definition. So if we take a look at the asset load listener for static meshes versus the one for the type listener here, which is right here, this does not actually have, let's see, we have the base ID and the instance ID, which is fine. That's essentially the functional equivalent of this. But we need these two items. So we need a callback, and then we need a mesh loaded, which I think we just call that model loaded. Or is it still called animated mesh loaded? Okay, so we still have some renaming to do there, but that's neither here or there. Okay, so the callback, if we look at the type of that, that's going to be an animated mesh instance. It's going to be the first parameter and then the context. So we have to build that animated mesh instance. So k animated mesh instance, right? And we could just do that this way. So we could say instance equals type listener instance ID, and then base mesh equals type listener base ID, right? And then we can just pass, actually we could just pass, oops, inst, and then the context, right? So this is essentially what we need to make sure that is passed back to the user code that initially kicked off the entire request. That also means that we need to store this callback somewhere. So I think when we do the acquire, oh, we do pass them. We do pass them. Then what the heck did we do with them? First model from package. What a dingus. We were passing them and not using them. Again, dingus-oriented programming for the loss. Listener. So we want callback equals callback, and then listener context equals context. Right? I think that's correct. Yes. Okay. So that is probably what we are missing. in its entirety, I believe. Let's see, acquire from package. I think, that's the only version of that. Okay, so actually, let's just build that. And I'm actually going to shut off these breakpoints for now. And we're going to relaunch. And let's see what blows up. Not much. Okay, so I don't actually know. Did that actually complete or do the thing? Let's see. We'll do animated mesh render data. We'll reactivate this breakpoint. And actually, I want to move this here instead. Right? So map count, that is still 0. So here is our animated mesh loaded, submesh material not loaded, placing in the queue. But did it ever actually kick off? Did it kick off the material for that animated mesh? Good question. Does not look like it did. I don't see it in here. Okay. So I guess probably what we should do is wasn't it in oh, it's acquire, not request. Animated mesh instance acquire from package. So I actually want to take this and I want to look at this unanimated mesh loaded. Was I already at the? Oh yeah, it's here. Okay. All right, let's relaunch this real quick. It's just quicker than doing it the other way. Okay, so this does get loaded. And then we do the mapping just like we do for the static mesh version. So animated mesh load context. There's the scene, there's the entity handle itself. Entity type index is 0. Okay, that's what I would expect. Wait a minute. That might actually be wrong. Entity type index. Oh, entity type index. Right, is just the index within that entity type. Okay, and this would be the first one. Okay, so that makes sense. Okay. So we get a pointer to the entity here. And then we do map entity geometries. So I'm wondering if there's a stupid copy pasta in here somewhere, some more dingus-oriented programming. Submesh counts. So that has 1. Okay, so that loaded correctly. So the geometry, that looks roughly correct. It is skinned geometry, which is what we want. Material instance. Base material is 2. I don't know that that's correct. But I can live with a invalid material because we can fix that afterwards if it's not correct. Let me see. Looks like I got some chat to catch up on. Oh, you guys are talking about AVX stuff. Okay. I'm not going to be able to read all of those, unfortunately. But awesome. Okay. So if the material is not loaded, which it's not probably going to be, then place it into a queue, animated mesh load queue. Oh, I wonder if we're processing that. So we put it into the queue, but I'll bet it never comes out. Yep. I'll bet that's it. I'll bet that's the issue. Updates. Process submeshes whose materials are waiting to be, or waited on to see who can be mapped yet. Okay. Yeah, so we're doing this for static meshes, but not, yeah. Okay, so we're not processing the queue. So essentially what happens is when we load up the mesh, at that point we request the material. If the material is not yet ready to be displayed, it's not yet loaded, then we place the mesh into whoops, that is the wrong there we go. We place it into a queue and say we'll just keep checking for whether or not this material is loaded in this queue. And then when it finally is loaded, then we can go ahead and do the thing and display it. So that is being done for static meshes, but not for animated meshes, right? So we have animated load queue, right? I think, again, this is probably just going to be just tacking on the word animated in front of everything. I'm going to scope this so I can rename it. Sure. And then this is going to be, let's see, animated. Let's see. Animated. Okay, this needs to be, oops. Submesh queue entry. Okay, and then was this map animated? Okay. So we got that. And I think that's it. All right. Let's load this. From like, it is a little bit quiet over there on that side tonight. Yeah, for sure. Not so much on the Twitch side, but yeah, the YouTube side's a little quiet tonight. All right, I'm going to take away that breakpoint because I think we might not need it. I'm just going to advance this a few frames. In fact, maybe I'll just disable this for a second. And, okay, all right. So we see something here. I'm not terribly surprised that that's foobar, given the fact that that we've just sort of invented a new format and we're loading that in. I'm not surprised at all that you know, our data is a little bit messed up. But what this tells us is that the whole process is hooked up start to finish, and that we do actually have everything hooked up system-wise that we need to actually load the asset. So as to why this looks like this, There's probably a few reasons for that. I think the first and primary reason is we're not using the right shader. So material renderer. Let's see. I guess we should probably do. We have material standard shader and material standard skin shader. Right, so if for these two things, we need to look at let me think about this. So when we go to apply this data, we need to actually make sure that we're using the correct shader, right? So I was saying we could use animation ID to do that. However, we don't actually have any way at this level to access that data. So I'm thinking for apply immediates, for bind base, that also does it, and then also apply globals needs to do it as well. Apply globals is a little bit easier because we can just kind of do that. So really it's just for bind base and then apply immediates that we need to actually switch that on. So I guess probably what we can do, and this feels super hacky and I hate it, but we're going to refactor this anyway at some point to make it a little bit better. So what I'm going to do here is I'm just going to do a Boolean, right? So we're going to just say B8 is animated. And I'm going to do the same thing. B8 is animated. Ideal? No, but it'll work for now. Oops, B8 is animated. And then down here as well. Right? And so all that we really have to do here is right before we use this, there's going to be a couple of places actually. So material standard shader. So what we'll do is animated. We're going to say state material standard skin shader. Otherwise, we'll use that, right? So we've got that one there. Same thing for, well, actually, water materials are just going to ignore that because water will never use that type of geometry, so that's fine. And then apply immediates is going to have that as well. Oops. So I guess we'll do is animated. Oops. Let's see. Yeah. Is animated. State skin shader. Otherwise, stick to the regular shader. And that's going to apply for both the standard and the water shader in this case. Okay. So that's going to break some stuff, which is fine. Should be relatively easy to fix, though. So the Illumina renderer is what's going to need fixing. I'm going to go ahead and kill this buffer over here. So we've got 4 errors. All right. So the water planes. So when we're actually drawing the water planes themselves, this is using the water plane material. So those are not animated, right? So that's nice and easy. Okay, so material instance level here is in the scene pass. And let's see, this is, oh, the same thing, right? This is the immediates for that same pass. So false here as well. All right. And then the next one is going to be drawing the geometry list. So this one is what is going to matter. So we have this, ooh, that's interesting. We don't know the animation ID until we're actually rendering the submeshes. And technically speaking, we could have animated meshes and static meshes in the same model file. Technically. The format supports it. Should we support that? Because if I don't, it's going to be a pain in the butt to add later. But all right, you know what? I'm going to do this. B8 is animated. And we're going to say material geometry counts is greater than 0, and we'll also say material geometries sub-0 animation ID is not equal to invalid ID U16, right? And this is a dirty hack. Looking at the first geometry to see if it is animated as a way of setting this flag may not be accurate for the whole material if, thinking about this now, I don't know if this actually, okay. If there are mixed static and animated geometries loaded from the same model. Fix for this would be to either combine animated and static shaders into a single pipeline, or to not allow mixing of static animated meshes in a model file, or to simply not use, or I guess, or to split these apart. Classified by static animated at the scene level, which we're actually already kind of doing, so we're kind of okay with it. This hack just kind of works because of that. So in this case, we're going to do is animated there, right? And then for the immediates, that's easy. We can literally just do geo animation ID is not equal to invalid ID U16, right? So we can just do that one in line. Okay, so that's one thing I know was definitely not correct. Because there's a different vertex layout for each of those shaders. So, segfault, sweet. Okay. But why? Animated mesh submesh is ready to be processed. Okay, so update descriptor sets. Descriptor writes 0. Destination set is null handle. How did that happen? The problem is by the time it gets here, binding index 2. Ooh, I just thought of another issue. I just thought of another thing that might be an issue, actually. Standard vert. So I'm going to pull up this one, and then also standard vert, the skinned version of it. Because I have a feeling I updated one of these and not the other. So base material data. I just need to make sure that all these structures match because I have a feeling that they probably don't. In fact, let's see. This is going to be the one that I know works. So let's take this and put it here. Pretty sure that's the same. However, what I'm not sure is the same. So, well, I know these two things are different. So we have our vertex inputs here. Finn is fine, raiding with a party of 29. Thank you so much for the raid. Welcome, raiders. What did you get up to on stream? There is a shout out. Am I following you? I don't know that I am. I am now, though. What did you get up to on stream? Welcome, readers. Working on UI stuff, making it all nice and stuff. Nah, sweet. Okay. Yeah, UI stuff can be a heck of a rabbit hole to jump into, for sure. Okay, cool. Well, I really appreciate the raid. Thank you so much. So what we are doing here, I'll give a quick and dirty sort of intro for those of you who are new to the channel. So what we're doing here is we're making a game engine from scratch using C, and we are using Vulkan as our initial rendering backend. And so the entire purpose of this is it's sort of an educational series on a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily always the right way to build a game engine. We do a lot of experimentation, trial and error, things like that. We try things out. Sometimes they work, sometimes they don't. We do a deep dive either way. But the idea is, to hopefully influence people to want to go out and make their own tech to compete with the big boys. And so the idea here is that, we show the entire process of building a game engine from the ground up, including all the debugging stuff, which is kind of what we're doing now, troubleshooting, that kind of thing. In addition to all of the shiny stuff that goes with it, of course. And so the engine itself is open source and free. It is available on GitHub. In fact, I'll drop a link here in chat to this main portal website. But the engine itself is Apache 2.0 license, which means it is free to be used on personal or commercial projects. It does not matter which one. The only thing that I ask is that if you use it, you say you used it. The whole idea here is that, it's meant to be used as an educational resource. With that being said, it is open source and free, always will be. There will never be any sort of royalties or licensing fees of any kind for the engine. And the goal with this is to not only build this engine, but use that tech to then build a game that we're going to take all the way to launching on Steam. And probably other platforms in the future. Speaking of platforms, the engine itself does run on Windows, Linux, and Mac OS. We are on Linux at the moment, but it does run on these three platforms. We do have other platforms planned for the future. And then I guess the other things on this website also are, just your typical follow links. We do have a Discord server with a little over 1,000 people on it. Of course, the GitHub link is here, and a Patreon link is there if you're interested in that. I don't have any sort of sponsors or anything aside from you guys. The game that we're going to be building, sorry for the flashbang, is called Shadows of Illumina. It is a 3D isometric action RPG. And we've already done a fair amount of design work, including world building, some lore, mechanics, item definitions, that kind of thing, controls, all kinds of things. And so the current thing that we're working on is we are integrating a new animation system that we've just put into the engine. And we've also developed a custom 3D model format that we're using with that as well. And so we're just kind of integrating all that and troubleshooting all the bugs as they come up. And that is the basic, quick and dirty intro. So I hope that all makes sense. Thank you guys for the follows, by the way. All right. So yeah, I hope all that makes sense. If you have any questions about it, feel free to go ahead and ask. Let's see. From Lake over on YouTube is saying support static and animated mesh in one file could really save on size for meshes that doesn't move in the object. Yeah, so that's the goal, right? So the format as we've specified it, right? The K3D format that we've come up with. This supports either static meshes or meshes that have animations. And technically it even supports scenes, for lack of a better term, that don't have any submeshes. So you could have one of these that only has nodes and a skeleton in it, and you could use those for other things, right? And so eventually we'll be using nodes for things like mounting weapons or something like that. That's kind of the idea behind this format. So the format itself supports it. It's just we have to figure out how we want to support it in the engine to make it make sense. Okay, so the thing that we ran into right as the raid happened is we actually hit a seg fault as we were sort of uploading the geometry data to, or at least I think that's where it was. I'm not exactly sure what's happened yet. We were just starting to look at that. So let's see. Yeah, Penguin, I can do that. Or if you, let me see. Hold on. I can do that really quickly. Or is your name the same on there? There you are. There you go. You got it. Okay. That's cool. How did you make all that, though? It took time. It took a lot of time. So I've been at this, as far as calendar years go, it's just under 5 years at this point. But, huge asterisk there. I work on this far less than part-time hours a week, right? So I only put in maximum of like 10 to 15 hours a week on this. So, if it was full-time hours, we're talking a little over a year of development, right? And realistically, if I were doing this without streaming and like explaining the stuff and interacting with chat and stuff, we're probably talking even less time than that in a realistic scenario. It's probably a few months worth of work, I would say. How much is the game going to cost after you make the game? I don't know yet. I haven't actually thought about pricing, to be completely honest with you. That is something that I have to carefully research, right? Obviously, it's not going to be like a AAA title price, right? That just doesn't make sense. But, I'll price it accordingly, I don't want to make it too cheap, but I am also going to do regional pricing too, because the same price doesn't make sense in all parts around the world. So that's going to vary based on where you are. Okay, so let's see. Why did this? Oh, right. Okay, so we got this segfault here about descriptor sets or descriptor rights being null. And so I was just kind of looking at the shader layout to see that these two things line up, right? So this is on the left is the standard vertex shader for static meshes. And then we have the skinned version of that over here, which can basically the biggest difference is in the vertex layout. We have these two extra properties here for bone IDs and weights of those bones for influence, right? So everything else should pretty much be the same. But I just did some updates on this guy, and I'm not 100% sure that I've gotten it correct all the way across. So I figured I should probably just look at that really fast. And this is the section I was thinking might be problematic. So we have, let's see, transforms, lighting, materials, animation data. So we did put animation data in here. Even though on the static side we never actually use this, the reason that we actually have it here is because we want these binding numbers to be the same. And that is because both of these, while the vertex shaders are different for these, they both use the same fragment shader. And so we basically need the data to line up all the way down. So let's see. Yeah, that actually is correct. Okay, so it's not that. There is one other thing I need to check, but before we do that, I think, all right, so here's the immediate data. Let's check the DTO from that. That looks fine. I think I've already updated that one. Okay, so it's not any of this stuff. Okay, so it's not that. Let's look at the material renderer. And let's see, I think, did we do this all under initialize? I think we did. So I'm actually going to pull this up twice. Two different buffers here. But I want to pull up the skinned shader. So this is the sort of configuration for that. This is how the pipeline gets built and all that stuff, because we don't actually have reflection yet. That is still something that I eventually want to get put in place. Okay, so that is different. Okay. So all of these properties should be pretty much the same. We have two stages, vertex and then fragment. That all looks fine. Here's the attribute counts. That looks fine too. Let's just make sure that this is actually doing the correct thing. Yep, attribute count. Okay, perfect. So bone IDs is int32 times 4. I don't remember if I used... Did I use a uint for that? Or... I think I used an int. And then weights is 4 floats. So that is fine. We have two binding sets. So for the first binding set, that's all of the sort of global level data, you can think of it as. So let's see, we have 9 bindings here. So we go ahead and set that up. And then here are all of the bindings. So the first one is going to be the UBO. Data size is going to be settings UBO. Okay, so that should be, the UBOs should be the same. And then we have the 4 SSBOs. So those all look good. And then we have the shadow cascade, or cascading shadow maps. So we have the texture and then the sampler for that. Texture and sampler for that. And then the IBL probe maps. So the texture and the sampler for that. Although I am seeing that this is commented out over here and not here. I'm not 100% sure why that is off the top of my head, but I'm going to do the same thing. That might be part of the problem, actually. Actually, I think I might know why that is. I think that might have had something to do... Oops, I need this one. Wait, why is that one... That doesn't seem right. This one actually should be an array, and this one I think should be an array too, and I think this should also be. Right, because this is a layered texture, but this is actually a texture array. Okay, so that should actually be that. All right, so that might have been a problem. In fact, it might have been the entire problem. And all that looks fine. Oh, looks like we're missing a step here, destroying the temp asset. Let's actually just grab... Let's grab all of this and replace this guy with it. Right, so that's going to be matte standard skin shader. One more. Okay. So we have that. We were leaking a little bit of memory there. Otherwise, I think that is pretty much good. So let's actually build that. Let's see if that actually solves it. I think that array bit was definitely an issue. Nope, still seg faults. Cool. Gotta love it. Let's see. Roxy, how's it going? First time chatter, welcome. Let's see. Let's see. So, wait, so what do you use to make a game engine? Do they make game engines or something? No, so we wrote all this from scratch. Literally, the first actual video where we start creating code, we actually create the GitHub repo. Like, we started this from complete scratch, including setting up the build system, all of the low-level systems, all the platform code, all the file handling, all that stuff. We build everything step by step from the ground up, literally starting from an empty folder with nothing in it. And so, yeah, that was the whole process that we started with. Let's see. I think any is going to be anywhere from $15 to like 40 USD. Yeah, I don't think it'll ever be as high as 40 for sure. Probably somewhere, maybe 15 or 20 bucks. I'm not 100% sure. We'll see where it winds up going. I'm going to do some industry research on that and some market research to figure out, what that should be. Gonna grab some food and lurk for a bit. Yeah, go for it. Definitely rest and relax after your stream. And thank you again for the rain. I appreciate that. Unless it's like a super small game, then it's sometimes a bit cheaper. Yeah, this is not going to be a small game, for sure. In fact, one thing I forgot to show. Takes a second to pull it up, but this one. Just to give you an idea of scale, this is the world map that we also built somewhat on stream. Um, and so, can I get rid of that? There we go. And so, yeah, we've got, this is the world of Illumina, right? And we've got 3 continents, each complete with their lore, right? This continent is pretty much done for now, I think. I do have some more details I want to fill in, but like the overall layout of it's done. This one's pretty much done. This, I still have some stuff to define. I think I'm going to shrink some of these other zones and make some other zones in here. But yeah, just to give you an idea of the world, this is the scale of the world so far. So yeah, just it's not going to be a small game. Let's see. So do you start with like a compiler, or how does that work? So yeah, basically, all we started with was just Clang, right? That's our compiler that we're using. So, I've got videos on how to set that up on Windows and Linux, because we initially only supported those 2. Mac OS came a little bit later once I actually got my hands on a Mac. But yeah, we essentially just created our first C file, ran it through the compiler, and it started off as a console app. I think it was like, let me see. You know what? Let me actually just pull something up. All right, so playlists. So here is the playlist, right? That has everything in it, minus the first, or minus the latest few videos, right? So let's see. I don't even think we actually got like Vulkan hooked up and clearing to the screen till like episode like 21, I think. Yeah, 21 right there. So, we literally start from things like overviewing of the architecture and what we think it's going to look like at that point. It's changed, but not too much, but it's changed. And then, setting it up on Windows, setting it up on Linux. And then the very first thing we did was like logging, because that's something you need, right? You need logging to debug and get information about the systems that are running. And then the platform layers to get Windows opening, right? Just all that kind of stuff, right? Setting up a memory subsystem with a custom allocator and that kind of thing. An event system, handling input, all of those various things. We basically start from very, very bare bones, and work our way up from there. Let's see. No worries, Psycode. No worries. Not a big deal at all. I do not mind you guys chatting. I can't keep up with quite that many messages, but yeah, don't worry about it. I do have to pause to like skip over it a little bit, but yeah, it's not a big deal, honestly. I love that you guys are having an awesome chat there. Is there a particular reason you chose C, or is it just because you like it? A few reasons, yeah. Most of it's preference, right? So my C++ that I wrote for years before I switched to C looked remarkably like C. So I called it C++ Lite, because I never used most of the new or advanced features of C++ because I just don't need them. And so the few features that I do miss out of C++ are operator overloads, occasionally function overloads for things like logging, and then constant expression. That's pretty much it. I don't do, like heavy object-oriented programming, so I don't need any of the class stuff or any of the, this pointer or any of that kind of stuff. I don't use templates. I don't use any of that stuff. So, my code was already very close to C. And when I went to go start this project, I'm like, I've been writing C++ that looks a lot like C for years. Why don't I just try writing this in C and see what happens? See what happens. And so that too was an experiment. And I said, I think I even said at the very beginning of the series, if I need to switch to C++ at some point, I will. But here we are, 4.5 years later, and I still haven't had the need to switch. So, but yeah, because of that, I switched to C, and then because C is so much simpler of a language, it compiles a hell of a lot faster, right? So, yeah, I hope that makes sense. Back from ads, and all I saw was like the first 2 seconds of you showing the world map. What I miss? Yeah, so I can show it again. No big deal. It's just a preview to give you a scope of the world, right? I should have looked over. I didn't realize ads were playing. So just to give you an idea of what the world is going to look like in terms of scale when it comes to the design of this game. So I've done, this isn't finished yet, but I've done a lot of work on this. I've created a lot of zones. So this continent is mostly done, at least as far as zone layout is concerned. Obviously, there will need to be some details that I'll fill in. This continent is small, and that's pretty much done, but there's a lot of rich lore behind that. And this continent is still very much under construction. There's entire sections like this I haven't actually finished yet. Some of these zones are probably going to be reduced a little bit, that kind of thing. And then this one is also needs a little bit more work. But just to give you an idea of the scale of the game, this is not going to be a small game, right? So that's just what we were talking about with that. And, you can zoom in and see details, right? And so there's, all kinds of things that we're going to be building out in this game. Yeah, that was basically it, though. It's actually a really cool story of how you chose C over C++. Really cool map. Awesome. I'm glad you think so. Thank you. Yeah, it's just I kind of chose C and never looked back. And these days I'm actually using C in my day job as well, so that helps. I think of the map and look at the map, and I think that's a lot of assets. Yeah, I mean, it is going to be a lot of assets for sure. I'm going to find ways to reuse things, creatively, so that I can kind of clamp down on that a little bit, but we'll see. I'm a C++ 26 enjoyer. I can't go back to C anymore. You could. You could, if you really wanted to. You could. So what's the game going to be like? I heard isometric camera or something like that. Yeah, so it's going to be a 3D isometric action RPG. At least that's the plan for now. So once we get to the point of being able to kind of prototype some gameplay, we're going to prototype a few different things and see what feels right and go with that. So, it is going to be an action RPG. The isometric part is not set in stone yet, but my initial thoughts behind that are something, like a Diablo-like or Path of Exile-ish, with, some differences, obviously. But yeah, that's the idea there. All right, I just noticed something. Binding index is 2. How many bindings do we have? 2. Which, if this is the second binding set, we should be correct. And it is. Okay. So why is that seg faulting then? I guess. Let's actually do base material. Oh, wait a minute. I wonder if... Oh, I just thought of something. I wonder if we have to... I think I might know what the problem is. And if it is that, that would suck. Bind base, let me see. Register base. Acquire binding set instance. Okay, that's the shadow pass data. That's the shadow pass. Crap. Okay. This was something I did not think about. Wait a minute, that's for the skybox shader. That might not actually matter. Wait a minute, that should be fine. Shadow pass, debug pass, editor gizmo pass. Acquire binding set instance. Right, so that makes sense the shader system should have that. Material renderer. This is probably where the issue is. So we have binding set 0 instances for shaders. So we do have this for binding set 0, but binding set 1 was the problem. Material renderer register base. And this does get shader for material type, which is only going to return that guy. And how do we know at that level which shader we should return? I knew this was going to come back to bite me. I think it might be time for us to consider combining these two shaders into one. Because all of this switching kind of sucks. And it'd be a lot more performant if we just use an Uber shader in this case. All right, so let me clarify what the heck I'm talking about. So let's go back to material standard skinned vertex. All right, and we'll do material standard vert. Right, this is the static one. So the issue is the inputs, and I'll put them both here towards the top of the screen. So the issue with this is for static meshes, this is what our vertex data looks like, right? So we've got our typical position, normal, texture coordinate, color, and tangent. For animated meshes, we have those same things, and then we have bone IDs and weights in addition to that. The problem with this is because of this difference in vertex layout, we have to have a completely different pipeline between the two, which means different sets of well, wait a minute. So we would technically have to, why don't I just do that? What I was thinking was I might have to actually let me think this through for a minute before I explain it. Okay. What I was thinking was we have to have these two different pipelines because of different vertex layouts. And I was thinking that we could combine them and not necessarily to have the same layout for all vertices, but we could also do something where we essentially take a second vertex buffer rather, and put in the extra data, right? So the bone weights and the bone IDs, right? We could just put those in a second vertex buffer, and then we can essentially just always use the first vertex buffer that contains this data, and then for animated meshes, we use the second vertex buffer data for the animated data. And if we don't have that, like we're rendering a static mesh, then we can just kind of bind some dummy data and forget about it and just not use it, which is kind of a common way of doing it. But I'm actually thinking now that we might not actually have to do that, because what we could do is when we go to create a shader instance for the material, right? We could just do it for both shaders at the same time. Because the problem that I was trying to get my head around was the way the material systems always worked. You have sort of material specific things that have to exist for a particular base material. So let's say you have a wood material and a metal material, right? Those are going to have their own sets of textures, their own sets of settings that exist for that thing, for that base. And then you have a instance of each one of those things, which has specific modifications to that for that particular instance, like animated texture coordinates or something like that. And so the problem is like, how do I... You could potentially use the same material on a animated mesh versus a non-animated mesh. And you wouldn't have acquired sort of the binding set instances for both of those things. But I'm like, now that I'm thinking about it, and I just had this brain fart, we could just acquire it for both. Right? So, because if we do acquire it for both, right? So we have the shader here that's being returned is going to be returned for material type, right? So we could add another thing to this that says, that says, B8 is animated, right? And then here we just do is animated, right? And then we do state material standard skin shader. Otherwise, if it's not animated, we do material standard shader, right? And then here, we would essentially do this operation twice, right? So we would do one where we say, no, it's not animated. Whoops. Not that. This call here. We do one that says, no, it's not animated, right? And then we'd also do a second one, right? So we do... animated shader, or actually it would be, I guess, the opposite, right? And then it would be static shader, right? So this one would be true. And so what we could do is static shader first, right? And then, why is that on a different line? That just looks goofy. All right, so we do the static shader first, and then here we do the animated shader next. Right, so that's going to be there. And we could just use the same binding set for both, right? Because we're doing them at the same time, the binding sets will always match, right? So one thing we can also do here is, let's see, I guess we only have the one material type, so I guess that doesn't really matter. So if we do this, we should have the resources gathered from both of those shaders. That way, no matter which one we're actually targeting, we can use it appropriately. And then when we do unregister, we would essentially do the same thing here again. So we just do, let's do rename, we'll say static shader, and we'll do false here. And then just call this again, and animated shader, and then take this and paste it here. Animated shader, and this will be animated shader. And then I would just move this down here in this case and only do that step at the end. Right, okay. So that should fix that. And then let's see, when we do apply globals, does apply globals actually have, yeah, we do have a shader here. So we technically have to do this step twice, which kind of sucks. Unless we're already doing that. No, we're not already doing it. Do we already have, yeah, so we do have these things, but we're not actually doing anything with them. This is why it was segfaulting right here. This and also the immediates for it. So let's take this and we'll put it here. And we're going to say animated standard shader. And we're going to do, oops, do we not have skinned? Wait, yeah, that, okay. So we do that, set wireframe on it. This needs to be what is that called? Material standard skinned shader. Whoops. Oh, it just adds the word skinned. Okay. Okay. So we need that done here. Thank you for the follow. Appreciate that. Let's see. If you dynamic branch on a uniform input, there's no warp divergence, and there's essentially no overhead for an uber shader. I know it's a bit late to think about that, but have you considered completely throwing away vertex input and instead use SSBO for vertex pulling? That would essentially remove the problem of inputting the correct attribute format and leave it up to the vertex shader variant to decide its data. You're not wrong. I do wonder, though. I do wonder if there's a performance penalty for doing that. Pulling it that way from a storage buffer versus a vertex buffer. I'd have to profile it, I guess. I don't even know where to begin setting up a simple enough application to profile that difference. I certainly wouldn't want to do it in here. an interesting point, though. Modern GPU, there can even be an improvement on tiled renders, possibly, because you skip that part of the input assembler. Yeah. Yeah, I kind of wish that I had thought about that. But it's like way late for me to do that now. That would be a huge refactor. I think eventually I am going to move away from having these split shaders, though. I do want to combine them at some point. I'm just trying to like not do that as part of this huge change set. But yeah, you're not wrong for sure. I kind of wish I'd gone that way now, but you know, going that way from the beginning though would have been much harder, I think. All right. Oh wait, why are we doing? This should just be shader. Why did we do that here? Right. Okay, did I get all these? I think I got everything I need. Okay, so this should solve that problem. And then in the bind base, that's also going to... Wait, did I do this right? Yeah, okay. In the bind base... Right, this is already taken care of by our other code. Okay, I wonder if that's caught everything. I have a feeling I might have missed something, but I'm not sure what off the top of my head, so let's try it. Oh, nope. In fact, that looks suspiciously like a mesh. It's goddamn huge, but there's our vertex data loaded, correct. Now it looks like we've got something else here. I don't know what that is, but there's our geometry, folks. That is what I was expecting to load, which is awesome. I don't know what the hell this is, though. No idea. No idea what that is. It looks like it might be... Actually, yeah, okay. We're not completely there. We're not out of the woods yet. It looks like some of the geometry is blown out somehow or something. I'm not 100% sure what's going on there. It could be like an off by one or something, but this geometry here looks good. I don't see any problems with it, at least as far as... Oh, wait a minute. Is that... No, that looks okay. I think that's fine. All right, so obviously it's T-posing, right? We don't have our animation playing yet, but we at least did load in the geometry. So I think the first order of business is actually to scale that way the hell down. So let's just go to zone 0, 0, sort of our test thing. Let's do... I feel like this needs to be really small. So let's go with like 0... I guess... Yeah. Let's try that.
You dingus.
Okay. Let's load this again. Well, that didn't seem to work. All right, why didn't that work? Why didn't that work? Did I not write the file? I thought I did. Thank you for the follow. Appreciate that. Peepo wide mesh. Yeah, exactly. Is that a tree? No, it's like a way oversized character model. For some reason, it is absolutely gigantic. I haven't figured out why yet. But let's see, transform. Yeah, so this should be position, rotation, scale. That looks correct to me. Oh, you know what? I'll bet it's possible that we're just not taking into account that yet. Let me look at the vertex shader actually. Guess we'll do material standard vert skinned. All right, so bone transform gets taken into account, and then we do have the model matrix. It's right there. All right, let me comment that out real quick. Comment out bone transform, and let me just try and see if that makes a difference. Definitely not. What did I miss? Oh. Dingus. What's it multiplying, right? There we go. I don't know why that quit on me, but there we have it. All right, let's see. Why? Bone transform undeclared identifier. What did I miss? Oh, there it is. Okay, you know what? Let me leave that, but I'm going to re-enable this. Right, and we'll just redo this. So that does not appear to have done anything. But why? So the problem is obviously not here. The only other thing that I can think of would be in here. Get entity transform. So we should have an animated mesh. Init-based entity should be doing this for us. In fact, yeah, it actually takes a transform. So, acquire from package, animated mesh render data, material map. Here's the entity. entity-based transform. It is. It is there. Yeah, because this isn't doing any differently. I'm thinking this is probably going to be a copy pasta error somewhere. Entity-based transform. Actually, so transform's supposed to be at the top level. Animate a mesh. Let me do... This is the old scene, I think. Isn't it? Deserialize entity. This is what I want. Okay. Transform. It's right there. Should be getting the transform for that. Invalid transform. Okay, let's check to see if maybe we got that warning in our logs anywhere. That's the only thing I can think of. Nope. No invalid transforms. Okay. Let's see. Let me catch up on chat. Are you using VS for the debugger? Yes, I am. He uses the one that shall not be named as a debugger because it's much faster than Visual Studio. Yes. Also, I'm on Linux. Should be using Rad Debugger if we're honest. Is that available on Linux yet? I haven't kept up with it, to be completely honest. I didn't think it would work on Linux. I know he's working on it, but I didn't think he was done. Honestly, I mean, this debugger is fine. It's one of the nicer GDB front ends that exists, I think. Unfortunately, it is, it works. Let's see. Yes, it's censored. Yep, exactly. Slyborg with a raiding party of 47. Holy crap. Thank you so much for the raid. What did you get up to on stream tonight? I hope I pronounced your name correctly, by the way. Welcome, Raiders. Nice beard. Let's see the hair. Yeah, I can do that real quick. It's decently long at this point.
You dingus.
I think it's about long enough I can donate it soon. Yeah. All right. Yeah, welcome, Raiders. Thank you so much for hopping in. I really appreciate the raid. I did get the name right. Okay, awesome. So just to give a quick overview, thank you guys for the follows, by the way. Give a quick overview of what we're doing is we are making a game engine from scratch. using C and Vulkan as our initial rendering backend. I say initial because I do have plans for Metal and Direct 3D support as well in the future. It is cross-platform, so it runs on Windows, Linux, and Mac OS rather. And we've built the entire thing essentially on camera, right? There is small parts that I'll do offline, but for the most part, I try to do most of the interesting stuff here online. So this is kind of an educational series that I kind of wish that I had when I was learning how to do this stuff, and it's just showing a way of building a game engine. It's not the only way. It's not even necessarily the right way. It's just showing a way of doing it. We do a lot of experimentation and trial and error. We try a lot of things out, and sometimes they work, sometimes they don't, and we investigate as to why. So the engine itself is available free and open source on GitHub. It is Apache 2.0 license, which means that you can use it for whatever you like, personal or commercial, does not matter. All that I ask is that if you use it, you say that you used it. That being said, it is very early days. So I wouldn't necessarily recommend using it as anything other than a resource at this point, but holy crap, 20 gift subs. Thank you so much for that. Footlong Icicle, thank you so much. That means a lot to me. Really, it does. Thank you so much. I really, really appreciate that. Yeah, holy crap. All right. Yeah, thank you so much for those gift subs. And if you guys got one of those, please toss them a big thank you. But yeah, let's see. Where was I? Thank you again for that. You immediately kicked off a hype train too, which is very funny. So yeah, the whole thing is designed to be an educational resource, right? So I don't believe in paywalling that stuff. So the engine itself is going to be free and open source. There'll never be any sort of paywalls or royalty fees or licensing or any of that kind of stuff. It's always going to be free and open source. We are developing a game. Sorry for the flashbang. We are developing a game called Shadows of Illumina, which is going to be a 3D isometric action RPG. And we've got a whole design here for that. I'm scrolling through it really quickly just because there's a decent amount of design that we've done on stream. And here is sort of the world map, just kind of giving a quick view of what the scale of this game is going to be like. So the idea is that we're building this tech all on camera, describing how it's done completely from scratch, and then we're taking that and using that to actually build and release a game on Steam. And this is sort of the world map, or at least the work in progress world map of that game that we're going to release on Steam. So I've done quite a lot of thinking about how the world's going to be laid out, and I've done some world building and some lore, and we've done some of that stuff on stream. We're going to do a lot more. A lot of the design is going to be taking place on stream as well. But yeah, that's kind of the project that we're working on right now. So yeah, I hope that all makes sense. Are the VODs on my YouTube channel? Yes, they are. Yeah. And that is, I think there's a link in the description or in the, what do they call it? The About section on Twitch. Lots of raids today. Are there normally this many? No, there's not. Usually. I usually don't get raided all that often, to be completely honest. But yeah, thank you again for the raid. I really appreciate it. Okay, so let me see. I think I missed a couple of questions. Missed the rationale for not doing vertex pulling. Anyone got a short summary? Yeah, so essentially, I kind of wish I'd thought of it earlier, but it also would have made it a little bit more difficult in the initial format that we started this series in. Because the series sort of started off in a tutorial format, and so doing it that way would have required a lot of front-loaded work that wouldn't have had sort of any visual reward for quite some time. So I kind of wish I'd done it. I wish I'd thought of it, but at the same time, even if I had thought of it, I don't know that I would have done it that way. Not to say that I won't in the future, though. Okay. Let me see. while I'm lurking you and sleep at the same time with the laptop. Nice. Appreciate that. Appreciate the lurk. Have a Discord? Yes. Gotta go, in other words. Yeah, no, that's totally fair. Yes, we do have a Discord. So it is, I think I have, did I put the command in there? Yes, there you go. So there's the Discord. And thank you again, Footlong, for that. I really appreciate that support. Thank you for that. If you bite the bullet and use buffer device address for the SSBO, you can skip the descriptor setup. Yeah. I wish, well, the other thing is when I started this, Vulkan 1.2 was new. So, a lot of this stuff wasn't quite the same back then. Suggested the raid because I'm learning C at the moment. Well, I appreciate that. Thank you so much. I appreciate the raid suggestion, rather. And welcome. Glad to have you here. Found that many code bases just use fat structures and not deep inheritance for entities. You also have the same approach. So, kind of. So what we have is, it's kind of yes, kind of no. We have like one level of what I loosely call inheritance, right? So we have this base entity, which has what you would expect a base entity to have. Things like, name, transform, various flags, tags, children, parent associations, which are all by ID. Extents an ID into the BVH tree. Some debug data that's just into our visual debug data, so like drawing boxes on the screen, things like that. And then our other sort of entities kind of will then use this here as the first member in the struct, right? So you can take any of these other entity types and cast them to this. And because the first thing here is Illumina entity type, this is an enumeration with known entity types. And so you can actually take that and just cast it to get the actual type instead of having to go dot type if you wanted to. And so that's kind of the way that we're doing that now. And I'm trying to avoid hoisting things up to this level wherever possible. The other thing I should mention is you'll note that the scene is named after the game, not the engine. This is a decision that I made not too long ago, actually. We used to have a sort of a generic scene that was included in the engine, and I decided that that was a bad idea because the requirements for your scene vary greatly depending on the game that you're making. And so I was like, well, the game also is aware of what kind of entities it's going to have and what types of entities it needs. So it makes more sense to kind of move that to the game code because the game is going to know what data it needs, how that data should be stored efficiently, and how that data needs to be accessed and transformed. And trying to do that in a generic way in an engine just gets bloated and heavy. So we just essentially removed all that bloat and rewrote that whole thing to be game specific instead. And that kind of fits the initial way that we are approaching this engine, where if you want to use a scene, use one. If you don't. Only we're not going to provide the scene. Now I may wind up providing a plugin that provides like a generic scene that you could use, but more often than not, this is the way you're going to want to do it. And I'll provide examples along with the engine as sort of a template to get started with once we figure this whole thing out. C doesn't have OOP out of the box, so not having deep inheritance makes sense. Yeah, we will not be doing deep inheritance for sure. This is like the closest to OOP that we get in the entire thing, to be honest. Shader syntax is super lame, but the functionality is absolutely goated. Fair enough. Let's see. Is C my main language? Yes. All right, Footlong, have a good one. Thank you again. Get some rest. Let's see. What do you think? What do you think announced? Oh, about Valve's hardware. Everything is PC and on Linux. I haven't had a chance to actually dive into that. I did see it, but yeah, I don't have an opinion yet because I haven't really read up on it. So, I would say ask me again next week when I have a chance to read on it. I'm looking at. I want to look into it this weekend actually. But yeah, I don't want to give an opinion on it because I'm not qualified to do that at the moment. All right. C is the goat, by the way. Yes, I agree. All right. So where were we? We were trying to figure out why the dang transforms won't work. So why won't the transforms work? So I should probably run this so you guys have a little bit of context, the raiders and whatnot. So here is what this looks like at the moment. So just to provide some context, we had, oh, that's interesting. So some interesting things happening here. Oh, I just figured out what all that is up there. Okay. So we had a sort of a freestanding static mesh system that was in place, where it was kind of rigid. We had an importer that read from OBJ files, and we just used that as sort of our first kind of get our feet wet format, right? Here recently, we actually created a file format of our own for models. Let me just pull this up. What we're calling models, right? And we're going to switch to this for both static meshes and animated meshes, right? But we created this model format. We've got a whole specification here that we laid out. And so what you're looking at here is actually our first, we actually literally just got this loading tonight. So we wrote an entire animation system, wrote the read and write and the importers for our model format, our custom proprietary model format, and hooked it up to the scene. So what we're looking at here is this particular mesh here, which is gigantic, was the first thing that we actually imported that way from our new format. So there's some issues with it, right, which is to be expected. And then I wasn't sure what the heck this was, right, but I think I just actually figured that out just by looking at the sort of wireframe that's going on here. So it looks like our tree that was down here, which is just a static mesh, is messed up. And I'm guessing that's because it's using the wrong shader to actually render that. So there's that. And then there should be a couple cubes down here, which, yeah, they're not rendering correctly either. If we actually switch to our wireframe, we can actually see that they're not showing up as they're supposed to, right? They're all foobar. So I think that's actually part of the problem. And I think what the problem is there is the vertex layout between these two things is vastly different. There are static meshes do not have as much data as animated meshes do. So I'm thinking it's probably just we are using the wrong shader to render these static meshes. So we'll have to figure out why that is. So let's maybe take a look at, this is going to be probably our custom renderer. Right, so this is the game-specific renderer, and it sort of knows, about the data that we're rendering and how to render everything and whatnot. So actually, it might be this. It might also be the material renderer. In fact, I'm actually leaning more towards that the more I think about it. So when we do apply globals, which applies the global level data that our shaders are going to need, or all of our materials will need. So things like, well, wait a minute. Let me think about this for a second. So this is also, we got a couple of fixed me's in here I have to figure out too. We set all of our global UBO data for both our static mesh shader and our animated or skinned mesh shader. And I think all of those things are set up correctly. Going to the correct instance IDs and all that good stuff. I have a feeling we're just using the wrong shader somewhere. So essentially we use the material standard shader, which is the static one. And then we set all this stuff on it. And then we use the skin shader and set all this stuff on it. And so essentially what needs to happen, what we need to make sure happens, is after we do this bind base, wait a minute. This is actually wrong too. Now that you think about it. This also needs to be done twice. So similar to how we did the static one and then the animated one up here, we actually need to do the same thing down here. Now that you think about it. So instead of having this is animated flag that we pass in here, that is not needed at that level. It is needed at this level, but it's not needed at this level. So if we go here, I'm going to get rid of this is animated because the base material needs to exist on both shaders as well. So how do I want to do this? Okay, so essentially everything that's happening from here all the way down to here needs to happen twice, but with a different shader, right? So I think the least annoying way to do this is we have K shader shaders 2, and we have this one, and then this one, oops, there we go, and then we can just do shader equals, and we'll just do shaders sub I. Now we don't have a sub I yet. We don't have a loop yet, right? But then all we have to do is come down here and just do for u8 equals 0, I is less than 2 plus I. And we can just go to this, come down here, which it doesn't actually know where to end that anymore. Right? And so we could essentially just loop it, right? And that way that same data gets applied to both shaders because we can use the same material on animated or static meshes, right? So it needs to be uploaded to both shaders. What doesn't have to be uploaded to both shaders is the immediates. So that is fine. So the immediates does need is animated. And that is okay to go ahead and do this. We have the use and then that's, and then we're good. So I don't think this is going to fix the problem. Oh yeah. We just have to back this change out, which actually this whole hack thing, this just goes away now. And Let's see, there was one more of those. Bind base. There we go. Okay. Let's see. Okay. Bring this back down. Okay. Is the tree still foobar? It probably is. Yes, it is. Okay, so I think we're still using the wrong shader, but let's check that. Let me catch up on let's see. For me, it's going to come down to price. There are sure some weird decisions, but they can absolutely be justified if the price is good. True. I would agree with that. Steam Machine is allied with all the efforts Valve already put into Proton for compatibility, so it does sound like a great move by them. Yeah, I would agree with that. They already put in all the software work to actually allow Windows games to run on Linux, and that has been awesome, by the way. Decaf bad, I see. Yes. That is what we use for that's what we use as our sort of magic number for assets, right? So even in our spec, the first couple of bytes, the first few bytes, is actually just this decaf bad, because decaf is bad. Wide peepo T-pose. Yeah, exactly. It is a T-pose because we're not applying the animation data yet, which is fine. In the past, you used Hyperland. What about now? So right now I'm using KDE. I did like Hyperland when I was on it, but that was like, I want to say a year or two ago, so it wasn't very mature yet. So yeah, it just had some issues that I couldn't quite work around. And also on an NVIDIA card, it was interesting, we'll say. Yeah, it is KDE Plasma. Exactly. Yep. Standard Pointer, how's it going? Good to see you. Welcome. All right. All right. Twitch's like stream preview is just freaking the heck out on my other screen, and it's just super distracting. I'm just gonna stop that, I think. All right. The stream is coming through fine for you guys on Twitch, right? It's not like acting glitchy or weird. It looks okay still. Sounds okay. Okay, so here is where we actually do the scene pass. So we render the skybox, and then we do the per material, or material, I guess we should call this, globals. Set cube map textures, apply globals. And I think we actually did yeah, we already have done everything in there. Okay, so that's fine. Draw geo list. So we do, let me think about this. So we draw the geometry list for the opaque meshes, which are static. And then we do the animated ones after that. And then we loop through and draw the water planes after that. Which is literally just applying the immediates, which we don't have an animation for that. that is working fine. We draw that. Then we have the geolist for the static, transparent, and animated transparent. Okay, and those look fine. I wonder, it makes me wonder if there's like an extra use that's happening somewhere that's just wrong. So we do bind base. You know what? Just because. Let's actually just do this. State materials standard shader. Shouldn't have to do this, but I'm just curious as to see if that's what it is. Nope, that's not the issue. Okay, so there's got to be something else going on. You can go ahead and get rid of that. Okay, let me think. So we've got... I guess what I should probably do is double check that these are loading what I think they are. So the fragment shader is here for the standard. This is the vertex standard, and then the skinned standard. And we don't have one for... Oh yeah, we do have one. For standard skinned fragment is the same as the material standard fragment, because we use the same fragment shader. So that should be fine. Okay, we are loading the correct one here. These are scoped, so we shouldn't have any copy pasta errors there. What is... I guess we might actually have to crank up render doc. Let me just build this real quick. Let's do that, actually. Ye old render doc. All right. So if we go into the forward pass, and we'll just look at the standard scene pass for now. That should be fine. These two right here are the tree. All right, so if we take a look at... Oh, wait, nope, that's not the tree. That's the large mesh. This one, I think, is the tree. Let's look at the mesh viewer. Yeah, that's all kinds of borked. And that's the input. So what does it think? What is it actually using? It is using the skin shader. So we're binding material standard here, that's correct. But then we're binding the descriptor sets for the... What? Wait, no, that's correct. This one's wrong. We bind the skinned. So, okay. Yeah, so we're binding the skinned material shader afterwards. And that's for descriptor set 1 in both cases.
You dingus.
Oh wait, no, we told it to do this. Right, because we have to upload that data to both. So that does make sense, but there's no switch back to the material standard shader before that draw call is made. Didn't I try that though? Thank you for the follow, by the way. Appreciate that. In big engines, they use game components so you can build entities data in runtime like in Unity. I find implementation of this not simple and reminds me of ECS's issues. Yeah, exactly. I am specifically avoiding that kind of stuff. For sure. I've actually been on a pretty large simplification rampage, I'll call it, where I've been just mercilessly deleting code and complexity out of the code base for quite a while now. And I've actually got quite a bit more that I want to do as we transition from some of the old systems to the new systems. Apply globals. So when we do bind base, that does the standard and the skin. So this is what we're seeing in RenderDoc before the draw. And then, so I mean, technically I could put a use back here, but that seems wrong. Because technically speaking, what should happen here is the immediates should be handling that for us. So if it's animated, it should be using the skin shader. If it's not, it should be using this. Then we have a use right here. And then set immediate data, which should be our push constants, right? So where is that in here? Push constants right here. But I don't see the use. Oh, wait a minute. This is going to be the standard and then descriptor sets, skinned and then descriptor sets, and then we bind skinned again. Oh, I wonder. Let's see. That right there, animation ID. I'll bet that's zeroed out. Let's see, that's the serializer. I don't. Yeah, we're not actually setting that anywhere for static meshes. That's the issue. This one here. So when we are setting up each geometry and material, here we go. So what we are missing here is this. Because 0 is a valid state, technically speaking. I'm going to kill this. No, I don't know that that's going to... Yeah, it did solve the problem. That's what it was. Because there's our tree. Sweet. So we've got that. We've got our cubes back too. So those guys. And that glitchy ass mesh to the side is gone. So that is pretty awesome. I still don't know why the transform isn't being applied to this guy, or where the heck his material is. It's sort of using this default material, which I'm not 100% sure why it's done that. But as you can see, it is rendering, and actually the geometry looks pretty good now, I think. I don't see any weirdness going on with it anymore. So that's good. So that at least means that our vertex data in our model format is good. So that's good. So it looks like our normal data might not be correct. We're not getting normals on it. Okay, so we'll have to look at that as well. Let's see. Dr. Elliott, good to see you. How's it going? In essence, Uber shaders are completely fine performance-wise. The problem is the register allocation. Due to the way graphics are pipelined, the register allocation needs to consider all possible control flow paths, even if you don't use them. Yes, that's one of the reasons branching is bad. So I try to avoid it, you know. If your Uber shaders start getting too big, you're going to suffer from over register allocation and lowered occupancy. Yep. Although I don't think we're going to be doing anything here that's all that crazy when all is said and done. Okay. Good old divergent branching. Yeah, exactly. All right. So we got the glitch fixed for our weird geometry. I guess I'm going to have to do render doc one more time, because I need to understand. Oh, did it just poop itself? Yes, it did. Nice. All right. Let me do it from here so I can see all of these things. And in the forward pass, let's take a look at this one is going to be the one that we want to analyze. And so the pipeline states, let's look here, and immediate data. Transform index is 22. So, I guess I need to go to here, and I don't know, I'll just select any triangle. It doesn't really matter which one. I guess I'll just do this one and debug. And let's see. So here's the transform index. And then here is the actual transform. Yeah, identity. That's what I thought. Oh, that's annoying. So why is it getting... If our transform index is clearly working, why is it getting an identity for that when we clearly don't have one set in the scene? It's probably going to be, the answer is probably going to be in here somewhere too. I guess what I could do, yeah, we did this. And I think we also did that in the animated mesh render data. Right there, yep. Oh, we didn't actually set animation ID here either, did we? I think we were lucked out. We were getting lucky because it was... Oh, we don't have an animation ID here to set. So that's going to be something we're going to have to figure out. Yeah. Actually, we don't even need this last line. Right, we're going to have some way of querying what animation is playing. Okay. I'll have to think about that for a little bit. That's something we don't have implemented yet either. We actually don't even have the play animation logic hooked up either. So I guess that's fine for now. Okay, so this is the winding. All right, so this should all be fine. The only thing I can think of is... deserialize entity. I guess I could try. I guess I could try putting a breakpoint here where the entity type is animated mesh. So we'll do a conditional breakpoints and we'll say entity type equals that. I just need to see what that's actually doing. Oh, nice. It didn't even hit that. Okay. What? Am I missing something? Okay, so we have a spawn point. Let's see, entity name. Static mesh. So let's just look in here, actually. So we have a spawn point. We had 2 spawn points. And then I guess it went all the way down to this one. Hit shape. Oh, that's here. Okay. And then, so the next one should be our test animation. Illuminate animate. Wait, it is an animated mesh. Why didn't that conditional breakpoint work? Help me understand this. All right. Okay, so the transform string. We did load that in, okay. So transform from string, that is going to output a K transform. So if we go here, so we're basically going to scanf all of our values, right? And so this basically reads the first 7 things, which is basically our position and our rotation, which it looks like it got those relatively correct. Actually, wait a minute, did it? No, it didn't. Six, 7, 8, 9, 10. Oh, position is, yeah, never mind. I completely missed this line. Okay, so position. Yeah, okay, that's correct. So it is, so it's position first, and then it extracts everything else here. Okay. So the count should be 10. So it should be rotation and then scale. Just did load those things incorrectly. Okay. So we do a handle create. I'm going to do 2 breakpoints here. Okay, so we got this one. I'm guessing that's going to be 22. Yep. Okay. So we've got that. So that should be, oh. Dirty list add. I wonder. I wonder if it's just not being updated. I wonder. I'm guessing that's exactly what the problem is. All right, so when we go to when we get this, I actually want to see what this gets. Maybe it's because we're not doing this. Even though we technically don't use it here. I'm betting it's just not updating correctly. I guess. I wonder if. Yeah, this is all fine. I think that's the issue. I think it's not updating. So when we go ahead and get the transform for that, the SSBO is not updated with the correct data, I'm thinking. Transform system. Updates. So this literally just does a copy of all of the world matrices out of the array to our map to memory in our render buffer, which is our transform global. Here it is right here. To do. Update the locals for the dirty transforms. Reset the list. Okay, so how is this working for our... How is this working for... Is this updates? Oops. Updates. Recalculate transforms. Root entities. I wonder if it's not processing root level transforms correctly. Because this is actually where the calculation happens. And then it's supposed to iterate the children. Oh, let me see. Random question, but do you remember what kind of shadow sampling you do? Testing out Vogel right now. So I'm using, what's it called? PCF at the moment. It's just super simple. Any transforms are handled by the system. I wonder what should be inside entity structure handled by the system. Well, all transforms are handled by the transform system. It's just whether, how they're related to each other is outside the scope of the transform system. And that's kind of where this comes in. But I think this is part of the problem. So if I were to do, I'm going to test this real quick. So I'm going to take, this, paste it here, and then do children, right? And then I'll take these, and I don't have to tab them in, but I just do it to make it a little easier to read. Right, I'm going to do that, and then rename this one to test and parent. I have a hypothesis here. So transform, I'm going to reset this to 1.0, 1.0, 1.0. Right, so I'm going to reset this scale to 1.0, and I'm going to set this scale to something smaller and see if that has any effect on it. Which I'm not 100% sure it will. I have a feeling the opposite is going to be true, but let's see. Oops. Get rid of that. Well, why has it done that? Why are we seg faulting? Did I do something stupid here? I don't think so. Doesn't look like I've done anything dumb. That should just work. Well, why are you being a dingus? And what the heck is seg faulting? Oh, right here. Property is stored of type object. Did I write something stupid here? It's just a single one of these. Oh. Should probably make that error a little bit more descriptive. Nope, that didn't do it either. No other errors? Nope. Well, for Pete's sake. What is it on about? Why are you seg faulting here, you dingus? It's like seg faulting. You know what? We haven't done this in a while anyways. Let's clean and rebuild. Alex, nice. That's awesome. Let's see. Alex, see ya. Have a good one. Yeah, definitely. Go get some rest. I think I'm going to end here shortly, too. All right. Let's see. Yeah, I don't understand why that's seg faulting. That must mean... Oh, wait a minute. Illumina entity. Wait a minute, that might be wrong, actually. Entity add child. Nope, that's not wrong. So we then push that into there. That should be fine. I'm not seeing why this is seg faulting. Scene. That's fine. Oh. I see. Where did that ID come from? What? Transform, okay. So this is trying to add the little child object here. Entity. No, I guess that is correct. That is very bizarre. This doesn't need to have a type. Should just need to have that. All right. I think part of this is I'm probably making stupid mistakes because I'm tired. All right, so if I remove this, am I just going nuts here? Is the guy just... Okay, methinks there's something going on with the parser there then. Because that should definitely not make that kind of a difference. All right, so if I take, maybe if I take this and put it inside of this, which already has, oh, this has got a larger scale. Well, all right, let's put it here. Try putting it here. What is that, probably 4 indentations over? Yeah. Seg faults again. So that's interesting. This only works if it's a base element. Why? That is an interesting bug. And I think that is probably where I'm going to put a pin in it, because we made really good progress tonight, I think. So I'm going to, I think, commit and push this up, and I think I'm going to end the stream for tonight, because I am tired. Had a long day, and I think we're at a good spot. So yeah, you did come in late, but that's okay. I'm actually streaming later than I normally do tonight, just because we had kind of a bigger crowd. So I really appreciate you guys being in here. Submarine over on the YouTube side, have a good one. I'm going to find somebody to raid, but while I do that, if you haven't already, I would greatly appreciate a follow and or sub on the YouTube side, and or the Twitch side, if you have not already. I'm just trying to grow the channel, so each and every one of those things definitely helps and are greatly appreciated. Let me see if I can find something that's loosely related to what we're doing here. It might be difficult at this time of night, honestly. Let me see who is on that. Oh, okay. Actually, I know who we're gonna raid. We are going to raid Moonwood Games. He's making a roguelike RPG that has blackjack as its playing mechanic, which is pretty cool. So we're going to go and see what he's up to. And yeah, thank you guys so much for being here. I really appreciate it. And I will see you guys in the next one. Have a good one. See ya.